Imagine you're in your backyard, holding a shovel, and someone tells you, if you keep digging straight down, you'll come out the other side of the earth. Sounds like something out of a cartoon, right? But what if we actually tried it? Could you really dig a hole all the way through the earth, from one side to the other? Let's explore what would happen if you tried to dig straight through our planet. The truth might surprise you. So, you grab your shovel and start digging. You're somewhere in the United States, and your goal is to dig through the entire Earth and come out in, well, where exactly? Let's pause here. If you started digging in North America, you wouldn't come out in China, despite the old myth. In fact, most points in the US would land you somewhere in the Indian Ocean if you went straight through the Earth. If you're from Argentina, you might actually end up in China. This exact opposite point is called the antipode. But before we get too excited, let's understand the journey ahead of you. As you start digging, the first few meters are easy, just soil and rock. Maybe you've dug a hole for a plant or a post before. But once you go deeper than a few hundred meters, things start getting more difficult. The temperature begins to rise, the rocks get harder, and oxygen becomes scarce. At around 12 kilometers, 7.5 miles deep, you'd reach the depth of the deepest hole ever drilled by humans, the Kola Super Deep Borehole in Russia. It took scientists over 20 years to drill that far, and they still only scratched the surface of the Earth. The temperatures down there reached 356 degrees, which was much hotter than expected and made drilling nearly impossible. Now imagine continuing beyond that. You're heading into the Earth's crust, which is about 30 to 50 kilometers thick on continents. After the crust, you enter the mantle. The mantle is made of solid rock, but it's so hot and under so much pressure that it flows very slowly, like thick syrup. Here, the temperatures range from 500 degrees Celsius, 982 degrees, to over freezing Celsius 700 degrees. No human has ever been there. No machine has ever reached it either. In fact, the heat and pressure would instantly destroy any normal digging equipment. Let's pretend you had a futuristic digging machine made of some magical heat-proof, pressure-resistant material. You continue downward. You pass through the upper mantle and reach the lower mantle, an even hotter, more pressurized region. Now, you're getting close to the outer core, which starts about 2,900 kilometers, 1,800 miles below the surface. But here's the catch. The outer core isn't solid. It's molten iron and nickel. That's right, liquid metal. At this point, it's not about just digging anymore. You're now trying to go through a sea of molten lava-like liquid metal at temperatures over 5,000 degrees and 9,000 rustigum. Even if your super digging machine could survive the heat, how would you move through a liquid that dense? It's not just swimming. This is heavier than any ocean and far more dangerous. But let's say, somehow, you push through. You're now halfway through the Earth and entering the inner core. The inner core is a solid ball of iron and nickel around 1,200 kilometers, 750 miles in radius. The inner core is also spinning, sometimes even faster than the rest of the Earth. Your journey would now take you into areas of physics and material science we can barely imagine. Your tools would be tested to their absolute limits. Now, here's something else to consider. Gravity. As you dig down, gravity would start to act strangely. At the surface, gravity pulls you toward the center of the Earth. But as you get closer to the core, gravity decreases. In fact, if you were at the very center of the Earth, gravity would cancel out from all directions. You'd be weightless. And once you pass the center and start heading up, toward the other side, gravity would begin pulling you backward, back toward the center again. If you weren't holding on to something, you'd fall back toward the middle. It's like trying to climb out of a giant well while someone is constantly pulling you downward. Let's not forget the pressure. At the center of the Earth, the pressure is about 3.6 million atmospheres. That's over 3.6 million times the pressure we experience at sea level. That kind of force would crush anything made with current technology. Still want to keep going? All right, if you somehow manage to survive and dig all the way through, you'd finally start to emerge on the other side of the Earth. But here comes another twist. As you dig upward on the far side, gravity would be working against you even more than before. You'd need extra energy just to keep moving forward. And as you come closer to the surface, you'd face new problems, like earthquakes, volcanic activity, and different types of rock formations. And let's not forget about temperature change. The closer you get to the surface, the cooler it gets again, just like when you started. Finally, after crossing all those layers, crust, mantle, outer core, inner core, you emerge somewhere in the southern Indian Ocean, gasping for air, exhausted, and definitely not dry. You're thousands of miles from land, possibly near a remote part of the ocean with no one around. So, can you dig a hole to the other side of the Earth? Technically, no, not with today's technology. The heat, pressure, gravity, and materials deep inside our planet make it physically impossible for humans to dig straight through. But it's a fascinating thought experiment that teaches us a lot about geology, physics, and just how little we truly know about our own planet. We've explored space more than we've explored the deep Earth. The furthest we've drilled is barely 0.2% of the way to the center. The rest remains a mystery, one of the last frontiers of exploration. So the next time someone says, "Let's dig to China," you can tell them, it's not just about the distance, it's about surviving a journey to the hottest, densest, most extreme parts of Earth. And until we have the technology to handle that, it's probably better to leave the digging to cartoons.